Let's go ahead and solve a couple of systems of equations by graphing. So obviously, the first thing that we're going to do is we're going to graph the two equations. When we graph them, there's going to be one of three things that are going to happen. Thing number one, they're going to cross in one spot. And if they do, we're going to find the coordinates of that spot where they intersect. Thing number two, we're going to have the exact same equation and the lines will overlap. We'll have infinite solutions. Or thing number three, we'll have parallel lines and there will be no solutions. Okay, so our first equation here is y equals negative 3x plus 10. And so that's pretty easy to graph. We've got a y-intercept of 10 and a slope of negative 3. Now, unfortunately, our graph only goes up to 6. So we're not going to be able to start with the y-intercept. We'll have to pick a different point. So let's see what happens when x is 1. So let's do y equals negative 3 times 1 plus 10. And that is 7. So when I plug in 1, I get 7. So let's start off with 1, 7 as one of our points. And then the slope is 3, negative 3, as a fraction, negative 3 over 1. So I can count down 3 and over 1 to get my second point. And then I'm going to use a ruler to connect the point. Since I'm going to solve this by graphing, it's really important to use a ruler. I want my graph to be as accurate as possible because I need to find the spot where these are going to intersect. So I really want as accurate a graph as I can get. Okay, our second equation is y equals x minus 2. That one is much easier to graph because my y-intercept of negative 2 is on the graph. And the slope is 1x minus 2. So the rise over run is 1 over 1. So up 1 over 1. There's my second point. And again, we'll get our ruler and we'll go ahead and connect these points. Just like that. So this is an example of a system that is consistent and independent because there is one solution. And where is the one solution? Oops. Let's make sure I can write properly. One solution. And the solution is right here, and that coordinate looks like 3, 2. So that's going to be our answer. 3, 2 is the solution to that system of equations. So we graph the two equations, we see the spot where they cross, and the spot where they cross is the coordinate 3, 2. Okay, so let's go ahead and graph our second one. Now, these are not in slope-intercept form. These are in standard form. So we've got a couple of options for how we could graph these. Option number one is put them in slope-intercept form and graph them. Option number two is that we can just find the intercepts. Since they're already in standard form, finding the intercepts seems pretty easy. So on the first equation, let's replace the x with 0 to find the y-intercept. So negative y is negative 1, so the y-intercept is going to be 1. Good. And then we'll find the x-intercept by replacing the y with 0. So that's 2x equals negative 1, so x equals negative 1/2, which is going to be right here, negative 1/2. Okay, let's go ahead and get our ruler and connect the dots. And there we go. And we'll do the same thing with the second equation, finding the intercepts. Let's replace the x with 0. To find the y-intercept, again, we could put this in slope-intercept form. There's nothing wrong with putting it in slope-intercept form to find this, but if it's already in standard form just makes it so very easy to find the intercepts. Why would we not? Let's do things the easy way. So x is going to be 6/4, which of course reduces to 3/2, which is the same thing as 1/2. So I'm going to put my point at 1/2, and then we will connect the dots. And lo and behold, what do we have here? We've got two parallel lines. And so when our lines are parallel, what does that mean? Well, it means we have no solutions, which means our lines are inconsistent. No solutions. The solution to a system of equations is where the two lines cross, and these two lines don't cross. So we don't have any solutions. We could write our answer either by saying no solutions, or we could just say inconsistent, because inconsistent means no solutions, and either of those would be fine.